Today we will see about histogram matching. Histogram matching is a technique used to transform the histogram of one image to resemble the histogram of another image. In simpler terms, you take a source image and modify its pixel intensities so that it looks like it has the same lighting as reference image. So basically they will give the two images. We need to convert the one image to another image by using the histogram matching. We will convert the one image to another image. Like if we see source image to reference image, we need to convert the source image to reference image. Like it should be look similarly. Why it is used means sometimes we want two images to have a similar appearance to match lighting conditions across a set of images to prepare images for comparison or blending. In medical imaging and satellite imaging for standardization. Like if we want two images to have a similar appearance, right? Then we will use this histogram matching and we will make it one image to equal to the same as reference image. And where it is used, mainly it is used is face recognition systems, medical and industrial image, visual effects in movies or games, pre-processing for machine learning models, etc. If you see example, there is a question. There are two histograms below. Modify the histogram 1 as given by histogram 2. So these are two histograms. We need to convert histogram 1 similarly like histogram 2. By using histogram 2, we need to convert histogram 1 same as like histogram 2. First we need to draw the graph images. So we got to know how the images are like. This is the first image, this is the second image. So we need to convert this first image similarly as second image. So first image should be look like a second image, like somewhat look like a second image. The process what we need to do is first step is equalize the first histogram. These are the gray levels. These are the number of pixels. These both should be given in the question only. And we need to calculate the PDF. We need to calculate the CDF. We need to calculate the SK into 7. And we need to calculate the histogram equalization. And this new pixel values. How many are there? So we know how to calculate the PDF, right? NK by N. These are total N value is 390. So NK by 80 by 390. Like that we need to calculate the PDF value. CDF value is 0.20 plus 0.20 plus 0.25, 0.45, 0.45 plus 0.23, 0.68, like that. We'll calculate the CDF. And SK into 7 is the CDF into 7. And histogram equalization value is nearest integer value to the SK into 7. Like 1.4 it is 1. For 3.15 it is 3. For 4.76 it is 5. Similarly for 5.81 it is 6. For 6.3 it is 6. For all this it is 7. If it is 6.5 greater than 6.5, that means it is 7. This is new pixel value is for 1 gray level how many pixels are there, like that. For 1 it is 80. For 3 it is 100. For 5 it is 90. For 6 there are two 6 values, so we need to add these two number of pixels. So for 6 there are 90 pixels. For 7 we need to add these 3 pixels. 20 plus 10 plus 0, that is 30. For 7 there are 30 pixels. So these are the new pixels we have calculated. Second step is to equalize the second histogram. These are the gray levels, these are the NK, this is the PDF, this is SK, CDF, this is SK into 7, this is histogram equalization. We know how to calculate the PDF, right? NK by N, we need to calculate the total N value here. And NK by N will do the PDF one. And CDF means we know how to formula, right? 0, 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 0.15, 0.15, 0.15 plus 0.20, 0.35, 0.35 plus 0.25, 0.6. Basically by adding the PDF only, we will get the CDF. Like for first row it is 0. For second row we need to calculate this PDF. So it is 0. For third row we need to calculate all 3. 0. For fourth row we need to calculate all 4, 0.15. For fifth row we need to calculate all 5, so 0.35. Like that we will calculate the CDF. We already seen before this one. For SK into 7 we will multiply the CDF into 7. For histogram equalization we will round off this the SK into 7 to nearest integer value. For 1.05 it is 1. For 2.45 it is 2. For 4.2 it is 4. For 5.6 it is 6. For 6.79 it is 7. So these are the new histogram equalization level values. Third step is mapping. This is the main step. You need to see carefully. we need to take we will take these two columns from the second equalization histogram and these two rows from the first histogram. We have calculated this, right? This is from the second table, this is from the first table. So these all are the values we have. And how to find the gray level means, first we will write the 0 to 7 gray values. And how to find the number of pixels means, we will see here. For 0 there is no histogram here, so for 0 we need to, there is no 0. For 0 there is 0 only. For 1 it is 0 only. For 2 it is 0 only. For 3, if you see carefully, for 3 the histogram level is 1, so we will see the 1 here. The histogram equalization level is 1, so we will see 1 in this row, this column. And this one value, new nk value is 80, so for 3 it is 80. For 4, if you see here, the histogram level is 2, so that we will see the histogram level here, 2 histogram level. There is no 2 histogram level, so we need to see the nearest integer value. For 2, the nearest integer value is either 1 or 3, but nearest integer value should be less than or equal to 2, so we will take 1 here. New nk value is 80, so for 4 also it is 80 only. For 5, if we see here, for 5 it is 4 histogram equalization level, and we have to see the 4 here. There is no 4 here, so we will see the nearest integer value, either 3 or 5. It should be less than or equal to 4, so we will take 3. And for 3 it is 100, so for 5 it is 100. And for 6, we will histogram equalization level is 6 only, and histogram equalization level is 6. We will see here histogram equalization level. For 6, you will see here the value is 90, so for 6 it is 90. For 7, the histogram equalization level is 7. We will see 7 in here, this row, this column. For 7, the value of number of pixels is 30, so for 7 it is 30. So based on this, we will draw a graph. For 0 it is 0, for 1 it is 0, for 2 it is 0, for 3 it is 80, for 4 it is 80, for 5 it is 100, for 6 it is 90, for 7 it is 30. This is the first image, so it is not exactly as the second image, but it is somewhat similar to the second image. This is the histogram matching. Histogram matching, basically it will do the one image to make similar to the another image. By referencing another image, by using another image, it will make the similar to the same that image. If you take A and B images, right, by using B image, A image should be converted similar to the B image by using this histogram matching. This is basically histogram matching. Thank you.